In this part, I want to do two things. I want to walk you through how you make a simple Lewis structure, and we're going to be doing this in lab or have done this in lab, so this may look familiar to you already. The other thing I want to do is point out this important thing about drawing Lewis structures. We kind of have these sister Lewis structures called resonance structures of the same compound, resonance structures of the same compound. So, for instance, let's go ahead and pick on formate. And this is something you might run into on the test. And we'll be talking more about this in lab, or we have talked more about this in lab. But one of the things I want to do right off the bat is to come up with that pot of valence electrons that I think I talked about before. So first off, with regard to hydrogen, how many valence electrons does a hydrogen atom have? Well, a hydrogen atom only has one electron, and it's a valence electron. So here's how I come up with my pot of valence electrons. The first number there is the number of those atoms we have, which is 1. And the number in parentheses is the number of electrons. So 1 times 1 is 1. Okay, carbon. How many valence electrons does a carbon atom have? Well, hopefully if you look on a periodic table, you're going to find carbon in 4A. So you're going to say it has 4 electrons, and there's only one carbon atom, so 1 times 4 is 4. Okay, now you know where I'm going next. Oxygen. How many valence electrons does an oxygen atom have? You have to find it on the periodic table to prove this to yourself. But it's 6A, so it has 6 valence electrons. So with regard to oxygen now, I'm going to write 2 times 6, because there's 2 oxygen atoms and they both have 6 valence electrons. Now in this case, drawing this Lewis structure, I need to add in for the charge. So there's a negative or -1 charge. So actually I have an extra electron in my pot, shown there on the charge line. If you add up all these electrons, you'll come up with 18 electrons. So again, just make sure we're all on the same page. That is my pot of valence electrons. Okay? And that actually is, those electrons are going to be shown on the final Lewis structure. Our Lewis structure needs to have 18. It can't have more. It can't have less. It has to have 18 electrons. So the first step in drawing a simple Lewis structure like this is to find out which atom you're going to put in the middle. And you need to have a periodic table. Your options of putting something in the middle, you can see I've already put carbon in the middle, but hydrogen never wants to be in the middle. And so our options are oxygen in the middle or carbon in the middle. And you always put the one that is least electronegativity. So maybe I'll put this lowest chi. And electronegativity increases as you go down, increase chi, and it also increases from right back to left again. So in this case, do you see where, highest electronegativity? Oh, did I put that right? I think it increases, okay. It increases from the opposite, I think it must increase from left to right, because you put the lowest electronegative, and carbon is less electronegative than oxygen. I hope I got that right. Okay. Well, we're going to put the lowest electronegative atom in the middle. Now, can you see, I'm going to call this a preliminary Lewis structure. And on my preliminary Lewis structure, can you see where each thing is how many electrons? Each bond is 2 electrons. So I have 2, 4, 6 electrons. So I have 6 electrons here shown on my preliminary Lewis structure. So here's where then I say, how many do I have left? Well, my pot was 18, that was the first slide. I used 6 on my preliminary Lewis structure, so I had 12 left over. Now, in lab, I'm going to kind of show this more steps than just now, but you can see how I have scattered or used those 12 extra electrons. Remember, I said it's all about, or not just but it's all about atoms getting a complete octet. Atoms want 8 electrons around them. And so if we take those 12 electrons and put 6 electrons here, okay, and 6 electrons here, that makes our oxygens happy. Now, when I say, let's see, how do I say this? The ones we're going to try to make happy first are what we call the terminal atoms. Terminal atoms. Can you see where oxygen and hydrogen are terminal atoms? Our central atom's carbon, so terminal atoms, so make them happy. Now, how many electrons does the carbon have around it? Well, right now, if I'm counting, this is 2, 4, 6. The carbon only has 6 electrons, okay? It doesn't have 8 yet. So this last step to drawing a Lewis structure, if that's the case, if your central atom does not have 8 electrons, what you need to do is to swing electrons in. So since it only has 6 electrons, notice if I can swing any of these lone pair electrons in to make a secondary or pi bond. Now when I do that, the oxygen still has those electrons, and now those 2 electrons I've swung in to make a pi bond are now shared by the carbon atom. If I do that, notice if I draw a circle now around the carbon atom, does it have 8? 2, 4, 6, 8. Yes, it has 8. Okay, so that's exactly what we're going to do. Now you can see that, because I couldn't remember which one I did, you can see that I've swung them from these electrons up here, from kind of, I guess, the north oxygen instead of the east oxygen. I swung those lone pair electrons in here, made a pi bond, it's a pi bond, okay, a double bond here, and now the carbon has 8 electrons. Does this oxygen still have 8 electrons? Yep, it's got 2, 4, 6, 8. Okay, so as I've drawn it, all of these atoms have a complete set of electrons. Let me go ahead and erase this. Now, one thing I didn't talk about before is check out this hydrogen. How many electrons does that hydrogen have? It just has 2 electrons. Is there a rare gas with just 2 electrons? And if so, what is it? Yes, there is. When hydrogen has 2 electrons like that, it is like the rare gas, helium, and it is very happy.